Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to talk today about business process redesign, specifically on process improvement. This chapter is actually designed to give you the overview of the requirements of group project in order for you to produce the as-is or the current process diagram, to provide the desired diagrams such as the cross-functional maps for the improved process, and the fishbone diagram to look at the cause and effect. I would like to begin by highlighting the 6 elements of strategies for change. It is more or less the same as the critical success factors for business project that we have learned earlier in chapter 1, but with additional 2 elements. The first element is critical process, second is strong leadership, third, cross-functional teams, fourth, information technology, fifth, clean slate philosophy, and sixth, process analysis. As the definition implies, process re-engineering is the fundamental rethinking and radical redesign of processes to improve the performance dramatically in terms of cost, quality, service, and speed. Therefore, the first element, the critical process, it emphasizes on core business and essential process. This is the first strategies for change. The second strategy for change is strong leadership, or if we can relate to the critical success factors for business project, it is the visible, active leadership. So we need this kind of managers to help us to overcome the resistance, to set and monitor key performance objectives for the process, and to create sense of urgency. Turning to the third strategy for change, which is cross-functional teams. It consists of members from each functional area affected by the process change. It may include people from finance department, marketing department, IT department, operations department, human resources department, or any other departments that were affected by the process change. PPR will work best when there are high involvement workplaces, when there are partnership participation, self-managing teams, employee empowerment, top-down direction, and bottom-up initiatives. So these cross-functional teams is very important for change in the organization. Information technology is another strategy for change in which it will lead to the success of the business re-engineering projects. It is a primary enabler of process re-engineering, who needs information network, who needs the computer technology, the information, when and where to get the information. So this is actually one of the business focus for the critical success factors for business re-engineering project. Let's move on to the fifth strategy for change, clean slate philosophy. What does it mean by clean slate philosophy? All knowledge will come from experience or the perception of the customers, of the internal or external customers. It is starting the way the customer wants to deal with the company, the customer orientation. So that is what does it mean by clean slate philosophy. Last but not least is the process analysis. This process analysis is one of the strategy for change in which the team members must understand the current process, what it does, how well it performs, and what factors affect it. This strategy for change will help the organization, the project team members, to identify what needs to be done, when and how to do it. Now, let's move on to the process improvement. Process improvement is the systematic study of the activities and flow of each process to improve it. Process analysis is the set of tools used to identify opportunities for improvement, document current processes, evaluate processes to find performance gaps, redesign processes, and implement desired changes. This is what we call as the systematic approach. And we have 6 steps of this systematic approach. First is identify opportunity. Second is defining scope. Third, document process. Fourth, evaluate performance. Fifth, redesign process. And finally, we have to implement changes. In order to improve the process, we need to analyze the process. So process analysis is the documentation and detailed understanding of how work is performed and how it can be redesigned. It is a set of tools used to identify opportunities for improvement, document current processes, evaluate processes to find performance gaps, redesign processes, and implement desired changes. This is what we call as the systematic approach to process analysis. So we have six steps. So we have 6 steps of systematic approach to process analysis. First is identifying opportunity. Second, defining scope. Third, documenting process. Fourth, evaluate performance. Fifth, redesign process. And finally, implement changes. Let's take a look at these 6 steps of systematic approach to process analysis one by one. Firstly, identify opportunities. It gives particular attention to 4 core processes. First, supplier relationships. Second, new service or product development. Third, order fulfillment. Fourth, customer relationships. So we need to look at the strategic issues, encourage employees who perform the process or who are internal or external customers of the process to bring forward the ideas. In defining the scope of process analysis, we will establish the boundaries of the process to be analyzed. We will assign resources that match the scope of the process, and design teams may be established for large re-engineering projects. After identifying the opportunities, defining the scope, here comes documenting the process. So we document the process by developing the list of the process by using flowchart, blueprint, or process chart. So what is flowchart? Flowchart is a diagram that traces the flow of information, the customers, equipment, or materials through the various steps of a process. Blueprint, on the other hand, is actually a special flowchart of a service process that shows which of its steps has high customer contact. And process charts concentrate in more detail on a smaller number of steps that does a flowchart. Okay, so that's the differences between these 3 charting. All right, flowchart, blueprints, and process chart. The 4th systematic approach to process analysis is evaluate performance. We need to identify the performance measurement that will be established for the process and the steps within it. Okay? So create multiple measures of the quality, how to measure higher quality, the customer satisfaction, how do we measure customer satisfaction, time, whether it is efficiently managed, all right, cost, how to reduce cost, error-free, zero error, safety, environment, flexibility, or any other key competitive priorities. After performance gap analysis, the new design should be documented as proposed. This is where we uncover the disconnects or gaps between actual and desired performance. This is where we find the root causes of performance gap. We might ask few questions in the process. What is being done, when it is being done, who is doing it, where is it being done, how is it being done, how well does it do on the various metrics of performance. So creativity can be stimulated by having a brainstorming session. So you need to generate a long list of possible ideas for possible improvement. Once the process is approved, the funding and the resources, it must be implemented. Here, the widespread participation in analysis is essential. It is important for the commitment and the expertise. Commitment must be developed and relevant resources should be available. Let's move back to the third systematic approach to process analysis, that is documenting the process but in detail. What does it mean by process mapping, flowchart? These words are usually used interchangeably. It is actually referring to creating a diagram that illustrates a business process, but the difference is flowchart will trace the flow of information, customer, equipment, or material to various steps of a process, and the process chart itself will concentrate in more detail that the flowchart does. Let's take a look at what is flow process chart. It is the document used in systems analysis that is useful for identifying each step in a specific work process using the following categories: operation, transportation, inspection, delay, and storage. For instance, this is an example of process chart of request tool purchase. We have the distance in feet, we have time in minutes, the symbol, and the description. Okay, let's take a look at one by one. Operation symbol is represented by circle. Transportation, right arrow. Inspection, a square. Delay, semicircle. Storage is the upside down of the triangle. Okay, if you look at the third description, it's to buyer. All right, so the distance to buyer is 75 feet. Okay, so that's the distance in feet to reach the customer. But there's no time stated here that maybe it take 1 hour to reach the customer, for example. Okay, so this is an example of process chart. Each of these 5 symbols has its own purpose. As for the operations, it is for changing the physical or chemical characteristics of an object. It represents the task. As for the transportation symbol, it is for the movement of an object from one location to another, from the production to the customer. As for the inspection symbols, it is to verify data or checking an object. As for the delay symbol, it is a situation that caused the next step in the process to be delayed. And lastly, the 5th symbol The storage is for storing or protecting an object. On the other hand, these are the basic symbols used for process map. We have the start or end symbol, arrow symbol, input-output symbol, process symbol, and the decision symbol. The decision symbol is a milestone symbol. Here, a diamond that indicates a decision has been made. So please use these symbols to illustrate the process map and the cross-functional map for the group project. This slide shows the additional basic flowchart shapes that you may use. We have data, start 1, start 2, direct data, manual input, manual operation, preparation, terminator, parallel mode, dynamic connector, and many more. Okay, so use these basic shapes when necessary. To illustrate this point on symbols, here is the example of cross-functional process map. So most of the time we'll use these symbols. We have the process symbol, decision symbol, and the arrow. All right. So what is the use of the arrow? It is to show the relationship between the representative shapes, the relationship between one process to another process, the relationship between the process to the decision. So here is the real example of cross-functional process map, which is on website changes. It has the department on the left side of the process map, and we have the processes inside. Okay, so basically what I have mentioned earlier, we have the process symbol, we have the arrow, and we have the decision shape. Alright, so the diamond shape that represent the decision. So starting from proposing changes to website to complete changes to the website is the processes. Next example is on pizza ordering process map, starting from placing the order up to receiving and checking the order, and that's the end of the process. So these activities are performed by a person or a group of people. So here for this pizza ordering process map, we have the customer, the registered clerk, the computer, and kitchen worker. Computer represent the application. Let's take a look at this burger process example. On the left side is the as is or the current burger order process, and on the right side is the improved process, the to be burger order process. If you look at these two, there's differences. There's an improvement in which they shorten the processes. So this means they might speed up the processes, they might reduce the cost, and increase the customer satisfaction. I would like to add on fishbone diagram that you may use in your group project afterwards. So it is also known as the herringbone diagram or the Ishikawa diagram. It is actually a visual way to look at the cause and effect. If you look at the fish skeleton over here, here we have the effect at the head of the fish, and we have the causes at the spine of the fish. Here we have the causes of policies, procedures, plan, and people. So this fishbone diagram can help in brainstorming to identify any possible causes of a problem and in sorting ideas into these useful categories. Okay? Most of the time, this fishbone diagram will help the manager to track down the reason for imperfections, for variations, for defects or failures. This is another example of the fishbone diagram. how to draw the fishbone diagram with the head that represent the problem and the spine that represent the causes, with categories outside the spine. All right, so a fishbone diagram is a structured brainstorming tool using categories to explore root causes for an undesirable effect, to discover the main reason, the fundamental cause, the principal cause, the basic cause of the problem. This slide shows another example of how to draw the fishbone diagram with the problem at the head of the fish, okay, and then with 6 categories, okay, materials, methods, manpower, machines, environment, and measurement categories. These are the causes with the branches of each causes of each categories. They have the primary cause, and the secondary cause, and you may have the tertiary cause. In this next slide, you will see the problem or the effect of iron in product and its causes. So the main causes, we have 6 main causes: measurement, materials, methods, environment, manpower, machine. So usually we'll use these main categories, main causes, and then we will identify the primary, the secondary or tertiary causes of the problems of the effect. Next example is on the colorful, beautiful purple fish, in which the problem is on pupils who are unable to handle and complete project work. So what are the causes of this problem? The method, environment, the man, and material. Let's take a look at the method. One of the primary cause is unclear project expectations, and assessment criteria is too general, for example, and they have the primary causes to it, and the secondary causes: process of doing project neglected, projects focused only on final product, no proper monitoring in doing business, and many more. More example on fishbone diagram. This one is for late for work. So among the causes are machines, methods, materials, mother nature, manpower, and measurement. So this person, he is using the 6M measurement for fishbone diagram. Okay, so let's take a look at the machines cost. Okay, so among the reason are car broke down, or he or she never changed the oil. So that are among the causes of late for work. And the last example for fishbone diagram is the part is produced wrong size. That is the problem, the effect. And among the causes, the categories are material, measurement, machine, method, environment, and people, or the manpower. Okay, so let's take a look at the people cost. Okay, so employee mistake, mistaken machine settings, mistake in production procedure are among the causes of these people categories. If you look at the material categories, among the causes are wrong specification of the material, poor storage conditions, and worn out material.